Journey to the Eclipse lecture series for 2023, because it's December. We will take a break for January because the students will not be back on campus the first Friday of January. And I would hope that you're all someplace fun with family or someplace warm. Or, and we will pick up again in February. So there will be a February, a March, and an April talk in the spring. So we're not done. We're just done for 2023. Okay, so stick with us. And then, of course, the big event, everybody's calendar, I hope, is marked April 8th, 2024, kind of an important date on campus. So if this is the first talk you've been to, welcome. Make sure you grab out on the table a list of all the fun activities that'll be going on campus during the total solar eclipse. We have an arts and crafts festival that weekend. We have a science and technology expo. There's a Comic-Con going on. All sorts of really fun things for the community. We hope everyone joins us. If you have friends or family coming to visit, drag them down to campus and get them involved in all the cool stuff we have going. Okay, so I would like to introduce our speaker for today. Dr. Ken Anderson was born in Australia. He got his PhD in Australia, and then he worked for private industry, and he worked for Argonne National Labs before he moved to SIU and joined us and brought all that expertise with us. He is a full professor of geology. He is also the director of the Advanced Energy Institute and the co-director of the Ancient Practices Program. So he's got his hands full. He's very busy, so I appreciate so much him taking the time to share with us. He's going to be talking about things that have affected the sun and the moon as we see them. So this will be very exciting, and I will let you have the podium.
Thank you very much, and thank you all for being here. I appreciate that very much. For those of you that are visiting SIU, welcome. For those of you that are visiting SIU again, welcome back. I see a few current and former students in the room. I trust that means you're not lost. But for whatever reason that you're here, I appreciate you being here. I hope I can share some interesting things with you. As human beings, we are creatures of habit. We like consistency. We like reliability. And we depend on that. And very little in our experience that's more reliable than the sun and the moon. The sun will come up tomorrow. We can depend on that. The phases of the moon, we can rely on that. We can predict that. The seasons come and go on a very regular, repeatable pattern that we know exactly what's going to expect and how we should expect that to occur. But there are times in the historic record when there are accounts of things that didn't go as we expect. And I'm going to talk about a couple of those today and try and explain a little bit about what probably occurred, what we think was going on, why it happened, and how it affected the people that experienced it at the time. Because in the modern world where we have scientific understanding of these phenomena and so forth, they're not so unsettling anymore. But in the past, when these kinds of events occurred and people had no understanding of them, they were very unsettling. So let me start by introducing you to the person who's primarily responsible for the first of the two cases that I'm going to talk about. If this would work for me. It was working. Right? Is it on? All right, we'll do this old school. All right, this is Alfred of Wessex, also known as Alfred the Great. And if you know anything about your medieval British history, which I assume you're all well schooled in, Alfred is the only king of what's now Britain to be given the honorific the Great. He was king in the 9th century for about 30 years. He had a reputation as a very learned man, a very gracious man, a very merciful man. He was responsible for stemming the incursions of the people we know as the Vikings, the Norse people, into Britain. He retook London and re-established that as a Saxon city. He instituted major reforms in the law and in education. But he's most important from our purposes for the moment in that he was a great lover of books. You got one that works? Excellent, thank you. And he commissioned this work, which we now know as the Anglo-Saxon Chronicles. And it was intended to be an annual history, a sort of a diary of all the great events that happened in Anglo-Saxon Britain and ultimately in English Britain over the centuries. And he started it, and it continued long after he died. And after a few fits and starts where there were some copies lost due to fires and so forth, a decision was made that what they would do with these chronicles is they would disperse them to various monasteries throughout Britain, and each monastery would be responsible for independently maintaining this work. And I'm particularly interested in the chronicle that was maintained at the monastery at Peterborough, sometimes referred to as the Peterborough Chronicle. And I'm interested in that because the entries for the years 1110 and 1111 AD are really remarkable. Now, if your eyes are better than mine and you read really quickly, you can read all of this while I talk, but I really don't intend you to do that. These are the entries, the entirety of the entries for 1110 and 1111. And my point here is not to make you read through all of this. As I say, my eyes aren't that good either. But this is everything. These are not chapters of the history. They're a couple of paragraphs at most. And if you look at the one for 1110, for example, that talks about where King Henry held court at Easter and Christmas, which nobles fell out of favor, and were deprived of their lands and so forth. And it talks about, it dedicates exactly one sentence to the fact that King Henry sent his daughter with a huge dowry to Rome to marry the Holy Roman Emperor. You would think that would be kind of a big deal, but it gets exactly one sentence. What's more remarkable is that for 1110, fully a third of the account of the history of that year is dedicated to a single event that occurred on the night of May 5th. Now, it's a bit long-winded and so forth, so let me break it down. We know that this event occurred on the 5th of May. We have an exact date. It's in the Julian calendar, so to convert it to modern, we have to make slight adjustments. I haven't done that. I've stuck with the original text. But we have an exact date. That's going to be really helpful. It being the moon, was a fortnight old, meaning it was 2 weeks after the new moon. So this was a full moon. The night was very cold. The trees that night were nipped by frost. So we know it was a very cold night. But we also know that it was a very clear night. Okay? The stars were shining brightly and were visible all night. It was cloudless and clear. And during that night, the moon vanished. In the early evening, the moon rose as normal and was shining brightly. Then little by little, its light disappeared until it was completely extinguished. Nothing at all of it was visible. And then by the morning, the moon had returned as normal. Now, it's easy for us to turn around and say, nonsense, who can rely on these old reports? But that's a lot of very specific details. A lot of very specific details. And I've tried my best to sort of reconstruct what the friars at Peterborough are trying to describe. Now, before I show you this animation, I will fess up, my skills with PowerPoint animations have their limits. But this is my attempt to try and convey what the friars at Peterborough experienced and were trying to describe of the night of May 5th, 1110, where the moon simply vanished out of the sky and then reappeared. Now, I know in an audience as august as this one, that you're all thinking, it's an eclipse. Your first clue might have been that this talk is part of a series called Journey to the Eclipse. Okay? So you could be forgiven for that. But if that's true, this is no ordinary eclipse. In a solar eclipse like the one we'll have next April, the moon comes between the sun and the earth. And we experience that the sun is blocked by the moon. In a lunar eclipse, the reverse is true. The earth comes between the sun and the moon. Okay? When that happens, light from the sun hits one side of the earth and obviously can't continue on to illuminate the moon. But there's this really thin veil of gas around the outside of the earth. It's called the atmosphere. You might have heard of it. Okay? And that has a very interesting effect at the very edges. Because what happens to the light that comes at the very edges of what I'm showing you here is that it passes through the atmosphere but never hits the solid earth. And as it passes through the atmosphere, what happens is that most of the wavelengths get scattered. They just get ricocheted off in all directions. But the long wavelengths, the red wavelengths, they bend and refract through the atmosphere. It's the same reason we have red sunsets. As the sun sets below the horizon, the last light is the red light that bends around through the atmosphere. That's the last light to reach us. And so what happens during a lunar eclipse is not that the moon goes into a complete shadow. What happens is that the moon turns red. It's called a blood moon. So if this was a simple lunar eclipse, this is roughly what the monks at Peterborough probably would have observed. As the moon's passing through the shadow of the earth, it turns red, which gives it that characteristic coppery kind of color. Now, blood moons are not especially rare. Okay? They happen a couple of times a year. They're not all equally visible from all parts of the earth. But most people are going to have a chance to experience a dozen or more in their lifetimes with a bit of luck and good fortune with regards to the weather. They're written about in the Bible. So the friars at Peterborough would certainly have been familiar with them. They wouldn't have been something so extraordinary that they required being written up and taking up fully a third of the historical documentation of that year. So what happened? Okay. Well, there's a clue in the next part of the Peterborough Chronicle, which says this year, 1110 AD, and the subsequent year in 1111, the weather was just awful. It was bitterly cold. It was cold through the summers. The crops failed. There was famines in Europe. You don't see famine mentioned here, but you do find in other records, particularly in France and Germany, experienced major famines in 1111 and 1110 AD. This was a regional problem, that these long, cold winters and cold, wet summers just caused tremendous problems for agriculture. And that gives us a clue as to what may have happened. But to figure it out in real detail, we need to go to another sort of record. And the record we need to go to is found in Greenland. And it's found in the ice in Greenland. There are a few intrepid earth scientists, geographers, geologists, and others who regularly travel to places like Greenland with gear like this, and they drill what's called ice cores. An ice core looks like this. It's just a cylinder of ice drilled out from the glaciers that exist there. Every year in places like Greenland and Antarctica and so forth, snow falls, and that falls on the ground, and then that will freeze into ice, and it'll form a new layer of ice. And every year a new layer builds up, just like the rings in a tree, perhaps, or pages in a book. And what we've learned to do as scientists is to go back and dissect these ice cores and peel off one page, of, if you like, at a time, and look at what's recorded in that ice. Because as that snow falls, it captures a little bit of the gas that's in the atmosphere at the time. Any dust or debris or anything else that's in the atmosphere will get caught in that. And you get little traces of that preserved in sequence through the ice. And when you do that and you look at what's in the ice, what you find is that from about 1109 through to about 1112, there's a big spike in sulfur in the ice. And that tells us that something was going on in the atmosphere at that time, because that type of signal occurs when you have big volcanic eruptions. Big volcanoes eject enormous amounts of gas and debris into the atmosphere, including little bits of ash and little bits of sulfur. And that gets preserved in these ice records. And we can dissect these records, and we can determine that around this time, there were a number of very large volcanic eruptions on Earth. We don't know anything about where they were. We only know that they occurred. And what that does, when that material all gets ejected into the atmosphere, the ash has immediate effects, particularly in the area around the volcano. The ash rains down, people get buried, things like that. No surprises there. But the sulfur, if the eruption is big enough, the sulfur will get ejected so high into the atmosphere, it goes up into the stratosphere, where there's no rain to wash it out. And once it gets there, it'll react with little bits of water and little bits of oxygen, and it forms sulfuric acid. And sulfuric acid is not very volatile. It doesn't want to be a gas. So what it does is it coalesces into tiny little droplets called aerosol. And that aerosol is just the right size and just the right composition that it reflects some of the sunlight that's coming into the Earth from the sun back into space before it ever gets to the surface of the Earth. And so what it does is it cools the Earth. And so after you get a very large eruption, one of the common consequences is that you'll have much cooler temperatures than usual, much wetter temperatures than usual in many places, and you'll have a climate disruption. But what's that got to do with a screwy eclipse? Well, that aerosol also has another effect. It scatters red light. So what happens during an eclipse is that, what happens during an eclipse is that that red light can't bend through the atmosphere like it does normally. It gets scattered back out to space. And the effect is that the moon disappears. Goes into complete darkness. So if we look back at our sulfur data, showing what was happening on Earth, and overlay that with all the blood moons that we know occurred around this time, some of which we can calculate, some of which are recorded in the chronicles. We know there was a blood moon in 1107, and that was a perfectly normal blood moon, referred to as such. We know there was another one in 1114, and there were two in 1117, all of which are recorded. And there's the dark moon in 1110, right on top of the sulfur signal. So we know now that what the friars at Peterborough were recording was actually the evidence that there had been not one, but probably several large eruptions in different places around the Earth at around that time. We don't know where they occurred. There's a very large eruption that occurs in Japan in 1109, and that's a good candidate for one of them. But the others could have been anywhere. We just really don't have any information about that at this stage. But we know that there were 2 or 3 large eruptions, and that cumulatively, they had the effect of putting enough sulfur into the atmosphere that it cooled the Earth's climate, which led to crop failures and famines in multiple parts of the world. I've only mentioned Europe here, but we know the same thing occurred in China and in Japan and other places. And we know that it caused a screwy eclipse, because the only thing in this part of the solar system big enough to hide the entire moon is the Earth. So the point I'm making here is that these kinds of effects, the things that change the way in which we experience the moon or the sun, isn't necessarily limited to celestial phenomena. There are things on Earth that change the way we experience the sun and moon as well. I want to go through one other example, sort of indicate the kind of impacts that these things can have. Okay, and I'm going to switch gears. I'm going to go a little bit further back in history here. And no prizes for guessing that the second case study I want to talk about relates to ancient Rome, and specifically to the assassination of Julius Caesar. Now, when you talk to most people and say, I want to talk to you about Julius Caesar, they usually say something like, oh, you mean the Roman emperor? And that's actually not true. Julius Caesar was never a Roman emperor. In fact, there were no Roman emperors at the time because the Roman Empire didn't exist. Because for about 500 years before it was an empire, Rome was a republic. It was governed by a pseudo-elected Senate that was overseen by 2 consuls who basically traded off power every other month. And that was sort of their check and balance. It wasn't really a democracy. I don't think that was more of an oligarchy. Who was elected was pretty much predetermined by who had the money. But anyway, it was a republic. And it was the assassination of Julius Caesar that triggered, or maybe was part of the event that led to the collapse of the Roman Republic and the emergence of the Roman Empire. And it was actually Caesar's nephew, Octavian, who became the first Roman emperor. Now, there are whole classes taught on the history of ancient Rome. I am not going to, trust me, I'm not qualified to teach those classes. And I see people in the audience who are far better qualified to teach that than I am anyway. But let me give you a quick rundown. Now, historians love to debate whether it was this event or that event, whatever, that triggered the collapse of the Roman Republic. And honestly, I don't care. I don't have a dog in that fight. However you look at it, by about 70 or so BC, the Roman Republic was in trouble. Okay. There'd been a series of reforms that had been instituted that were populist in nature, that were not sitting well with the Senate. The military was playing an ever-increasing role in politics, domestic politics in Rome. And in 70 BCE, 2 Roman generals, Pompey and Crassus, were made consuls. So you've got 2 generals serving in executive office, if you like. That wasn't the greatest situation in the world, but it was made worse in about 60 BCE, when another very popular Roman general called Julius Caesar joined this and formed the first, what they called triumvirate, where these 3 generals were sharing executive power. 3 is always a crowd. 3 egotistical Roman generals working together was never likely to be a recipe for great stability. In 53 BCE, Crassus got himself killed, which left Pompey and Caesar, and that led to a breakdown that led to the start of a civil war. This is when Caesar crosses the Rubicon. Okay. And Caesar defeats Pompey and has himself appointed essentially dictator for life in 44 BCE. The Senate is infuriated. The people love it. Caesar is very popular, but the Senate hate it. And it doesn't take more than a couple of months before senators decide to take matters into their own hands. And Caesar gets stabbed in the rotunda. I'm told it's a very painful place to be stabbed. Okay. Okay. The populace are upset by that. Brutus and Cassius are forced to flee Rome. They race out. And Caesar's nephew, Octavian, and Mark Antony, of Cleopatra fame, and Lepidus seize power and form what becomes the second triumvirate. Okay. Now, they go to war with Brutus and Cassius. That leads to Brutus and Cassius being defeated. Mark Antony heads off to Egypt for reasons that will become clear in a moment. While he's gone, Octavian strips Lepidus of power and sets himself up as essentially as dictator. Mark Antony and Cleopatra sail back to try and get things sorted out and establish themselves in power, but Octavian defeats them. And by 27 BCE, Octavian is now taken the name Augustus, sets himself up. He doesn't call himself emperor initially, but he's essentially got the powers of an emperor. And by 19 BCE, he's set up himself as the first true Roman emperor. Now, all very political, and in typical Roman fashion, all very bloody. But it's missing some important details. Superimposed on this, we need to recognize that there were some other phenomena going on that show up in the record that are probably significant. The first is that right after the assassination of Julius Caesar, there are a series of portents and omens that are observed, all of which involve the sun. Okay? And Octavian is very quick to declare that these are omens that determine that he should take power. Okay? We'll talk about what those are in a second. From 43 and 42 BCE, there is extreme cold and crop failures throughout the Roman Empire. You see in Italy and in Rome itself, there are food shortages and famines in some areas. In Egypt, which is kind of the breadbasket of the Roman Empire at the time, the Nile fails to flood for 2 years in a row, which leads to famines there, so they can no longer export grain to the rest of the empire. This is causing major and major problems. And it's into that scenario, this highly stressed society, that Octavian, Mark Antony, and Lepidus insert themselves and take power. Anthropologists refer to that as a state of exception. A state of exception is a time in the history of a society when there's some sort of disruption. It can be physical, like a war, or it can be natural, like famines and so forth, that prevent the normal functioning of society. And when those occur, they're usually associated with periods of rapid change in a society. You see dynasties fall and rise, as you see in this case. So the question I want to ask is, amongst all this political machinations that are going on, there's also this backdrop of natural disruptions. And what's driving those? What's contributing to those kinds of effects? So first of all, let's talk a little bit about what was actually observed. Okay, so there are a number of Roman authors that talk about the immediate aftermath of the assassination of Julius Caesar. And there are lots of reports of these weird effects involving the sun. Several authors report that the sun is darkened after Caesar is assassinated. Okay, you know, it's hard to refer to anyone who's just been stabbed to death as being lucky, but you can't fault Caesar for his timing. Okay, he got that part exactly right. Okay, other contemporaries of Caesar and from the assassination of Caesar, they record that, you know, reports of 3 suns or a halo, a ring appearing around the sun. And the people at the time, people like Octavian, were very, very quick to say, you know, this is important, this is a sign from the gods, this is, you know, the gods telling the people that I should be emperor, which is opportunistic, to put it mildly. Okay. In reality, all of those observations are consistent with the effect of very large volcanic eruptions. Okay. So this is Iceland in 2010. This is volcanic darkness. When a volcano erupts, the ash is opaque, just finely pulverized rock. And sunlight doesn't pass through it very well. So if you happen to be under the ash cloud, it's going to get dark. And in some cases, it can get very dark. After the eruption of Tambora in Indonesia in 1815, large parts of what's now Indonesia, what was then the Dutch East Indies, were pitch black for 3 days. Reports of not being able to see your hand in front of your face. Okay. More commonly, though, you get sort of a dimming of the sun. You sort of get this fog effect, or just that the sun is pale and more like the moon, and just not giving off its normal warmth and light. And that's the effect of ash and dust and ice and moisture in the atmosphere, producing this sense of darkness and gloom. 3 suns? That looks like 3 suns to me. This is an effect called perihelion. When a volcano erupts, the single biggest thing that comes out of a volcano is usually water vapor. Okay? That gets lofted to very high altitude. And once it gets up there, the ash starts to drop away. That's heavy. It's made of rock, so it sinks fairly quickly. And that water vapor is now very high. It cools down very quickly, and eventually it starts to freeze. And when you get these little ice crystals in the atmosphere, when they reach the right size, they refract sunlight. And the effect is called sundogs, or 3 suns, which matches exactly what the Roman authors described to us. The ring around the sun, since 1883, that phenomenon has been known as a bishop's ring. Okay. It's caused by the same thing. Ice crystals in the atmosphere, just in this case, they're more diffuse. So you don't get the refraction into 3 suns, you get this kind of effect. But it's just caused by water in the atmosphere. All of these things are consistent with the effects of large volcanic eruptions. So, is it conceivable? Do we have any evidence that there was a large eruption that might have affected what people in Rome were experiencing at the time? Well, it turns out, yeah, there's a pretty good candidate called Mount Etna. It happens to be erupting right now if you're following the news. Mount Etna is the largest volcano in Europe, okay, or one of the largest anyway, depending where you draw the boundaries around Europe. And it had a significant eruption in 44 BCE. As I say, you can't fault Caesar for his timing, okay? Had other characteristics maybe not so good, but you can't fault him for his timing. It wasn't a huge eruption, but it was close to Rome. And the timing is absolutely perfect. This is a more recent eruption, and this is from 2020. And this is a smaller eruption than the eruption in 44 BCE, but it's still a significant event. You can sort of see what's going on here. The volcano erupts, it ejects a lot of material. The bottom part is ash. You can see the ash falling out. The material above that is mostly water vapor that's condensing things. Even this is too small for the eruption in 44 BCE. It would have been bigger than this. Not a huge eruption as volcanic eruptions go, but it still would have been significant, and it might well have had some impacts around Rome because it was close to Rome. I need to digress for 1 second here. We need some sort of system to say, how big of an eruption are we talking about here? And geologists recognized the need for some sort of scale many years ago, and they called something called the Volcanic Explosivity Index. It's too much of a mouthful, even in geek speak. So everyone abbreviates it to VEI. Okay. And like the old Richter scale for earthquake, it's a logarithmic scale. It's based on how much material is ejected. A very small eruption will have a 1 or a 0, and it goes up in every step on the scale is 10 times bigger than the one before. We know from geological studies that the eruption of Mount Etna in 44 BCE was about a VEI 3, a little bit smaller than the eruption of Mount St. Helens in 1980. So not, a big event, but not an earth-shattering kind of event, not really astronomical. Okay. So now we can go back to our timeline here, and we can insert the eruption of Mount Etna into this. And Mount Etna is a pretty good explanation for the portents that were observed in Rome, for the parhelia, the 3 suns, and for the ring around the sun and the darkening of the sun and so forth. Mount Etna is a pretty good candidate for that. Timing is good, the location is good, seems to fit. But we still have a problem. If you read in detail the accounts, the effects in Rome after the assassination with Caesar were not short-lived. They stuck around for a long time. In fact, they stuck around for several years. We have here Plutarch's history of Julius Caesar, in which he records that the sun was weak all that year and that crops failed as a result. Fruit trees did not produce fruit. And that's consistent with what we know about the famines, of the food shortages and so forth. And Mount Etna's eruption, as significant as an event like that is, particularly if you're close to it, if you're close to any volcanic eruption, it's a significant event. Take to your heels, okay? But as significant as that event was, it's just not big enough to have the kinds of effects that Plutarch is describing, okay? And we have other records from other parts of the Roman Empire. We have the failure of the Nile floods. We have famines in Egypt and so forth. Etna is too far away to account for those kinds of effects. So clearly there's something else going on here as well. So we go back to our ice cores. We go back to the science. And what we find when we look at the ice cores for this period of time, we find that there is a monumentally large eruption that occurs in the first few weeks, or first few months of 43 BCE. Now, in this particular case, we're fortunate because the ice cores in Greenland not only capture sulfur, but they actually capture particles of ash. It actually settles out in Greenland. Not very much, just a few stray particles, but that's enough for a good geochemist to analyze and identify exactly the nature of the rock that was ejected. And that was done by a scientist named Joe McConnell out in Arizona and his team. They collected these few stray particles of volcanic dust, analyzed it, and then compared that with samples that had been collected throughout the world from eruptions that we were aware of. And what they found was a perfect match to a volcano called Okmok in the Aleutian Islands. So now we know that Okmok, which would have been uninhabited or mostly uninhabited at the time, erupted in the first few months of 43 BCE, and it was a huge eruption. This is a satellite photo of the caldera that was produced. A caldera, if you're not familiar with it, when a big volcano goes off, all the magma that's underneath gets ejected out, bang, 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 psh, big spectacular display, leaves a big void underneath the mountain. And rocks don't like standing on nothing. So what happens is after that magma's all been ejected, the mountain collapses, falls in on itself, creates what's called a caldera. The caldera at Okmok is 10 kilometers across. Not the biggest in the world, but it's still a pretty impressive caldera, just the same. And we now can date the eruption precisely. Because we know exactly where it is and exactly when the eruption occurred, we can also feed that information into climate models. And we can model the effect of the eruption on climate at the time. And what you find is that most of the Northern Hemisphere, but particularly the area around the Mediterranean, experiences dramatically colder temperatures, 2 to 4 degrees C colder than usual. That's going to play havoc with agriculture. Doesn't sound like a lot, but a summer that's 4 degrees colder than it should be means crop failures. Your crops just won't grow like that. You can look at trees that were growing at the time. Okay? We find the wood still preserved in archaeological settings. We find it in peat bogs and so forth. We can core down through those trees and we can look at the tree rings. When a tree grows, it puts on an annual growth ring every year. If it's a good year, hey, I'm putting on a lot of wood. If it's a really bad year, very thin tree rings. And what do you find for 42, 43 BCE? Very, very thin tree rings. All throughout Europe, all throughout North America, all throughout Scandinavia, all throughout the Mediterranean. This was a widespread cooling event that had dramatic effects. You can model it more precisely for the Mediterranean, looking specifically at the Roman Empire at the time. And what you find is, yep, Egypt got it, Rome got it, Greece got it. Throughout the Roman Empire at the time, it was cold, it was wet, it was a bad year for agriculture, which matches precisely what we hear in the historic record about famines and food shortages and all the other things that we can find from other historical sources. Matches precisely. So now we can add Okmok into our timeline. Okmok goes off in 43 BCE, 43, 42 BCE, crop failures, severe cold weather, food shortages, famines, state of exception. And that's when Octavian, that's when Mark Antony step in and set themselves up as the second triumvirate. They take advantage of the disruptions that are caused not by the political machinations, not that they're unimportant, but by the environmental disruptions that are caused by something that affected the sun. Now, to be clear, because I know I've got a classicist sitting in the room with me, I am not saying that a volcanic eruption caused the collapse of the Roman Republic and the rise of the Roman Empire. It's much more complicated than that. Those political machinations, they count. They matter. It mattered that someone stabbed Caesar in the Rotunda. But you can't ignore the fact that Roman society was under extreme stress at that time as well, not just from the political machinations, but from the environmental perturbations that were going on as a result of particles in the atmosphere that were affecting the amount of sunlight that was reaching the Earth and cooling the climate as a result. So the question is not, did the eruption of Okmok cause the collapse of the Roman Republic? That's not true. The question is, to what extent did these different factors weigh into the overall disruption of Roman civilization at the time that led ultimately to the collapse of the Roman Republic and the rise of the Roman Empire? It's not that either the science or the history gives us the entire answer. It's a question, you need both. both have something to contribute to this story. And we can learn from both when the two work really well together. And that's what the two case studies that I've tried to share with you today demonstrate, or at least I hope that they demonstrate. So, yes, there are celestial phenomena. Yes, we're going to have an eclipse next April. That is going to come between, the moon is going to come between the Earth and the sun, and it will darken the sky, darken the sun for us, and we'll have a great experience. But there are other phenomena that also affect the way we experience the sun, the way we experience the moon. And these terrestrial events also cast a very long shadow. Thank you very much.
Okay, so when you have questions, I'm going to try to bring the mic to you because we do have people tuned in on Zoom as well. So forgive me while I run around like crazy. So come on over here.
Ken, thank you very much. That was simply magisterial. About the
Isn't
lack
that what
of
they said to Caesar?
magisterial, yeah, I should avoid the term. About the lack of the Nile flooding.
Mhm.
So what causes that? Is it reduced rainfall in
Reduced
the
rain,
East
yeah.
African, or is it the reduced temperatures meant that the snowcap didn't melt, causing the
in
flood?
this case, it's reduced rainfall in East Africa, in the areas that the Nile headwaters. And this is, we can model what happened in 43 BCE, but we can observe this in events since then when the Nile has failed to flood after large volcanic eruptions cause climate disruptions. And we can see where the lack of rainfall is from actual empirical measurements, and it's lack of rainfall. What happens is after a large volcanic eruption, some parts of the world will experience excessive amounts of rain, and others will get zero rain or complete droughts. Overall, the effect is cooling, but it's not uniform. It's very spotty. In 1815, after the eruption of Tambora, in Europe, it never stopped raining all summer. It was historians refer to it as the last great subsistence crisis in Europe, meaning Europe couldn't feed itself because it was so cold and wet. And every time they planted, it rotted in the ground. In North America, we had drought. It was very, very dry. We didn't have that same kind of effect. Cool, we had what they called a year without a summer. We even had some snow in June and May in New England, but we didn't have the rain. So it's patchy. And in the case of North Africa, what happens is you get lack of, that causes the Nile not to flood.
Other questions?
So you're all ready for the quiz then?
We did warn them. Oh, wait, no, we forgot.
I don't,
Okay.
Ken, I just want to say a brief word. I appreciate that you did not leave politics out of your book.
Thank you, John. Wherever two or more are gathered together, there shall be politics between them.
Fantastic presentation. You should be on TED Talks for sure. But based on this research and what you've put together, would it be safe to assume that there's going to be a massive volcanic eruption and a political assassination in April?
My crystal ball gets fuzzy looking forward. I tend to look back. We are looking at an eruption in Iceland in the relatively near future, so who knows?
Right. This is fantastic. What about, are there other events in history like Krakatoa that can be tied to affecting human civilization? And
Absolutely, absolutely. History is full of them. The connections haven't always been made until relatively recently because we didn't understand all the connectivity between these things. But I'll give you one more brief example. I promise to be brief. In 1783-84, there was a huge eruption in Iceland, okay, much like the one that's likely to happen in the next few months, but much, much bigger. Iceland is prone to kind of, instead of volcanoes that sort of erupt as of a big column, what happens is you get a crack and you get what's called a fissure eruption. And it can be, it can occur over many months as the crack opens up and the eruption sort of moves along the crack. 1783-84, there was a big one at a place called Larkin. You've probably never heard of it. Even the Icelanders who lived there at the time had never heard of it. And it was way up in the sort of back of northeastern Iceland. Almost no one lived there. There were plenty of earthquakes and warnings. People got out of the way. There were essentially no casualties, few livestock. You know, the eruption really was a non-event. And yet it killed a quarter of the population of Iceland and about 250,000 people in Europe. Because what happened is, as this eruption continued over months and months and months, the amount of fluorine and sulfur and other gases that got ejected started to accumulate. That led to poisoning of water supplies in Iceland and led to making the air in Europe, quote unquote, bad. And if you look at the death rates in Europe, it just spikes. And there's about 250,000 people die sort of above normal trend in that summer. It was particularly hot summer in Europe, and sulfur from Iceland was coming down. It was making the air very acidic. It was bleaching plants, and anyone with any kind of breathing problems just turned up their toes. So yes, there are lots and lots and lots of examples of this from eruptions in all different parts of the world at different times in history. And you can make the same argument about some very large earthquakes that disrupted social structures and led to sort of an overturning of governments and dynasties and so forth. Yeah, there are a lot of examples of this. We live in the environment, and anything that disrupts that environment disrupts the way we live.
Do we have one more?
For the graph showing the global climate effects after the Omoak volcano, a lot of the like loss of temperature also occurred on the eastern part of Asia. Are there any records of that historically having?
Yeah,
been?
the records from China are much less well known. Chinese scholars know them. And have studied them, but there's just less dissemination because they're less accessible to the rest of the world because they're in ancient Chinese. So we have just less understanding of those records. But yeah, there are records that show that the Chinese at that time experienced famines. They experienced a year without a summer. Their crops failed. They lost cattle. They lost fruit trees, which were difficult to replace. And these had long-term consequences, which ultimately led to the collapse of one of the Chinese dynasties.
Politics and climate tied in again.
That's right. Saving the best for last, David?
Yeah. Yeah, but listening to this, it raises a kind of an interesting question. Couldn't you then make the argument that burning fossil fuels is doing the same thing, just more slowly?
Yes, and people have made that argument. Like I said, we live in the environment. Anything we do that disrupts our environment disrupts the way we live, and that is consequential.
One just thinks of, we hear a lot about the crisis of our border with Mexico. But what we're actually seeing is massive movements of population because their environments are changing.
That's right.
And nobody seems to want to talk about that.
Yep,
which is too bad.
Yeah. After the eruption of Tambora in 1815, there were about 20 to 30,000 immediate casualties on the island. But even the survivors were unable to feed themselves because their rice crops had been destroyed, their cattle were all dead, their horses were all dead, and so forth. They were just completely destitute. So they jumped in what was left of their boats and they sailed across to Java, to places where they thought they'd be able to get food. And there were about 60,000 refugees that sort of packed up and moved to Java. That led to huge social conflicts on Java because Java was also badly damaged by the eruption, barely was able to sustain itself, could not sustain this enormous influx of refugees, which led essentially to civil war between the refugees and the locals. So yeah, anytime you get a migration of humans on a large scale, it's disruptive, and it usually equates with times in history where there's a lot of unrest, a lot of upheaval, ultimately a lot of wars.
All right, if we could please thank our speaker, and I'm sure he'll stick around if you have additional questions.
Thank you very much.
Thank you for coming.